Standard 8 students, myself Ramakant sir, going to teach you physics. That is our chapter 3, force and pressure. Already we have discussed about the pressure, its SI units and all. Now I shall tell you about Pascal's law. Blaise Pascal was a reputed scientist as well as mathematician. He enunciated a very important law. This is called Pascal's law. According to his law, if pressure is applied at any point on an enclosed liquid, it is transmitted equally and undiminished in all directions. Once again I am saying you, all of you look at the board. If pressure is applied at any point on an enclosed liquid, I mean in a container, it is transmitted equally and undiminished in all directions. So for this I shall tell you one experiment. To verify this law, now we will see one activity. Everybody, what is the material required for this activity? Number one, a long-necked glass flask fitted with an airtight piston. This is one airtight piston and having a glass bulb with a number of holes in different directions. It's the number of holes in different directions. So everybody look at here once again. If we push the piston, and once again I am saying you, if we push the piston inside this, you will see that water transmitted, I mean water comes out from this bulb in equal directions. This means we can say that according to this Pascal's law, here the water comes out from this hole in all the directions. It is thus we can say that Pascal's law is verified. Various instruments also we can see in our day-to-day life, like hydraulic press, hydraulic brake, hydraulic jack. These all based on that is Pascal's law. Now we will say that atmospheric pressure or pressure exerted by gas. For this we will see now the different diagrams. Now pressure exerted by gases or atmospheric pressure. We know that our earth is surrounded by 300 km thick layer of various gases. This is known as atmosphere, which is held to the surface of earth by gravitational pull and exerted force on it. Thus we can say, what is atmospheric pressure? The force exerted by the atmosphere per unit area of the surface of earth is called atmospheric pressure. So the atmospheric pressure exerts pressure in all directions. The SI system or in SI system, the value is about 1,01,325 Pascal at sea level, or we can say approximately 1 lakh Pascal at sea level. So for this we will tell an activity. I shall tell you an activity. So everybody look at this activity. Now look at here. To show this the atmospheric pressure, now the material required is a thin walled tin can. It is a thin walled tin can and a tripod stand. This is a tripod stand and wire gauge. This is a wire gauge, because for uniformating wire gauge is required. A Bunsen burner and water. Now the procedure I am saying you, everybody remember. Fill the can about 1/3 water. Heat the can with the lid. Now first you put the lid. Now first put the lid, I mean cover the lid. Inside this water is there. When water is heated, first water boils, then steam forms. When steam forms, then take out the lid now. We will see that the air is expelled out inside this container. We can get only the liquid is inside here. Understood? No air is inside this container. Now the lid is covered. The lid is covered means no air is inside the container. So atmospheric pressure, I mean the outside pressure is more and inside pressure is less. What I told you, the outside pressure is more and inside pressure is less. This more pressure, now if you see this more pressure, now crossed this tin container. For better understand, I can say you, now sprinkle some cold water into the container. When the cold water sprinkles over it, we will see that due to the condensation, now the pressure, outside pressure and inside pressure varies. This means I can say you, while boiling, conclusion part everybody see, while boiling the steam expels out all the air present in the can. When cold water is poured over the can, steam condenses to form water, thus creating a vacuum, I mean low pressure. Thus atmospheric pressure act on this can. Due to this more atmospheric pressure, it is crushed, or it is called crushed in experiment. Hence we can say that there is exist an atmospheric pressure which crushes the tin can. So understanding the atmospheric pressure, day-to-day life, many examples are there which we can see the presence of atmospheric pressure. For example, I can say you might have seen when we are taking the cold drinks with a straw. You might have seen when you are taking the cold drinks with a straw, when we are just taking the air from the straw. This means the inside pressure of the straw is reduces. Outside pressure becomes more. When the outside pressure means atmospheric pressure becomes more and inside pressure of the straw becomes less, which forces the lemonade, I mean soft drinks, to get inside the straw, thus we can drink the cold drinks. So many examples, you might have seen the fountain pen, the same examples here, the atmospheric pressure is there. We know that if you go higher altitudes, the atmospheric pressure decreases. Once again I am saying you, the atmospheric pressure decreases with increases in altitudes. That is why when the mountain climbers, if they will go without any, suppose their mountain suits, then there is a chance of nose bleeding. Because why? Because in above or higher altitudes, the atmospheric pressure becomes less, our body pressure becomes more. So thus the blood comes out from this nose. Always remember, if you can think about the more atmospheric pressure, how we can survive. Always our blood pressure is slightly more than the atmospheric pressure. Hence we can survive. Otherwise, when if you go higher altitudes, it will be a more problem. That is why we are taking some special type of suits. There the pressure is adjusted. Similarly, when we are going the higher altitudes with a plane, in a plane the cabins are pressurized so that we cannot determine the lower atmospheric pressure there. Why? Because the cabin is pressurized. Always you must think that even if for better condition, our blood pressure must slightly more than the atmospheric pressure. Thus we cannot determine so much pressure. As I told you, it is about 1 lakh Newton per meter square at sea level. About it is. So due to this high pressure, we are not aware about it due to this reason. So many more examples are there in our day-to-day life. So existence of this atmospheric pressure. To measure the atmospheric pressure, we need an instrument. What is that instrument? That instrument is called barometer. This means barometer is an instrument which is used to measure the atmospheric pressure. I shall tell you the construction of the barometer the next class. Okay, this much. Thank you.